Let's take a look at another example. At what time Maple Leaf Village had North America's largest Ferris wheel? The Ferris wheel had a diameter of 56 meters and one revolution took 2.5 minutes to complete. Riders could see Niagara Falls if they were higher than 50 meters above the ground. Sketch 3 cycles of a graph that represents the height of a rider above the ground as a function of time. If the rider gets on at a height of 0.5 meters at t equals 0 minutes, then determine the time intervals when the rider could see Niagara Falls. Alright, so for this one I think, even though they're not specifically asking, I think it would be a good idea to get the equation of this. Then eventually we sketch it, then we sketch 3 cycles, and then we can determine this part. Okay, so there will be several videos for this for sure. Let's begin collecting our data. So first, the Ferris wheel had a diameter of 56 meters. So I suggest to make a sketch. On your notes of this. I always suggest, it's always very good to make a sketch. Now you will see a lot of examples that are very similar to this one. Let's take a look at this one. So there's my Ferris wheel. Okay, here's the axle. Okay, I'm gonna have to erase that, and here are the different carts of the Ferris wheel. Okay, this is a little bit too big. And that's our Ferris wheel. These are the different mechanical parts, I guess supports for this. They all meet at the axle. And okay. And they say that the diameter of this thing is 56 meters. That's the ground, by the way. So let's label this. So from here to there, that's the diameter of our Ferris wheel. They say it has 56 meters. 56 meters, okay. They also say that it took 2.5 minutes to complete one revolution. So maybe right below this, as a reference for now, we could say that the period is equal to 2.5 minutes. Okay, let's leave that as a reference. What else do they say? They say that the riders could see Niagara Falls at 50 meters above the ground. Okay, I think we don't need that for now. Sketch 3 cycles. Now, this is important. If the rider gets on at a height of 0.5 meters at t equals 0. So, in other words, the riders get on here at the bottom of this part. So we know that this height, this is obviously not to scale, this is 0.5 meters. That's where the riders get in. So that's the lowest point. Okay, so now if we're going to sketch this at least one cycle, we're going to need the maximum and the minimum points. We're going to need the equation of axes. So let's start collecting that data for now. Right, so first we would say that there's one information that we have here, and that is the minimum point. So the minimum point would be 0.5 meters. So let's put this here, 0.5 minutes. Okay, what would be our maximum point? Where our maximum point would be if we are already at 0.5 meters above the ground and the diameter is 56 meters. So we need to add 56 to 0.5, which gives us a maximum of 56.5 meters. Okay, that's our maximum point. So actually, let's label this as our maximum point. This will be our minimum point. Now we also need our equation of axes. So that will be basically where the axle is located. So let's draw a line there. What would be our equation of axis? Well, equation of axis would be, in other words, y equals c, right? This is our y equals c when we're sketching it. Therefore, it's going to be y equals what? Well, the formula for c is what? max plus minimum divided by 2. So we can do that here on the side. Hopefully you guys can see this on your screens. Let me move this up a little bit more. That's good. So C is equal to the maximum value, which is 56.5, plus the minimum value, 0.5, divided by 2. Well, when you put this in your calculator, you should be getting 28.5 meters. So that would be our equation of axes. So our equation of axes will be 28, y equals 28.5 minutes. Sorry, I said, no, meters, pardon, meters. And why did I put minutes here? That's kind of weird. It should be only, maybe I meant to write minimum. It's supposed to be meters. This is supposed to be meters as well. Okay. And what else do we need? I think we've got everything that we need in order to get all the other information that we need to sketch this and to graph this and to get an equation. Now, there is one essential thing, and this is what I mentioned that it is important. The rider is getting on at 0.5 meters at the bottom. When time is equals to 0, see this, you guys can see this here. When time is equal to 0, the rider is getting on at the lowest point. Okay, so think about the 4 basic trigonometric functions, of the 4 basic functions. Which would be best to represent this if the rider gets on at the bottom of this, and if we're going to keep track of the rider's height, well, then if the rider gets on here, then if this is moving, let's say this way, counterclockwise, let's assume, right? Well, as it moves counterclockwise, right? As it moves counterclockwise, we're keeping track of the height. So we start at the bottom and then we go all the way to the maximum point, and then we return to the bottom, right? So we go up and then down. We start at the bottom, then we go up and then down. So which of the 4 basic functions best represents this phenomena? I would say, and you would all agree with me, that the base function for this, the best one, you can use any of them, but the best one, the easiest one, would be y equals cosine x. And let's sketch it to have it as a reference. I always recommend to do this, and by this you should know this. You should know this by now. Start at the bottom, then you go at the top, reach the maximum point, then you go down, and then just label it, right? Since we're using radians, it takes 2 pi, to complete one cycle. Halfway in between this would be pi. Halfway between these two, pi over 2, and this one, 3 pi over 2. I won't label the whole thing, but you guys should know it, right? So this is our base function. Our parent function, our base function, okay? Let's put it there, mine as well. And that's it, just as a reference. Okay, good. So now that we have that, we need, well, we already know the maximum, the minimum point, the equation of axes. We know that, we got it from the previous example. We also, we need to find out the period of this, because, well, we need to find the period. We have the period already. If we're going to write the equation, as I said before, we need to find the value of k. So just quickly, right, let's figure out. So if the period is equal to 2 pi over k, and we need to find the value of k, then let's substitute p, right, which is 2.5 equals 2 pi over k. That means that k, let's put it here, that means that k is going to be equal to 2 pi over 2.5, and 2 pi over 2.5, if we want to keep it, if we want to avoid the decimals, 2 pi over 2.5 is the same as saying, so 2.5 is the same as saying 5 over 2, so this is like 2 pi over 5 over 2, which is the same as saying 2 pi over 5 over 2, that's the same as saying 4 pi over 5. 4 pi over 5. So we've got everything. And since we know that our base function will be y equals cosine x, and this is our k value. So that means we're going to use this. We're going to use this as a reference. Y equals, oh sorry, once again, this is not equals y equals cosine x. This is y equals minus cosine x. Pardon, since we start at the bottom. Ugh, I'm rushing a bit. Usually I don't try to go as fast, but right. So this is y equals negative cosine x. You start at the bottom, then you go to the top, and then at the bottom again. So our function would look like this. Y equals a cosine. We know that a is going to be negative. Y equals cosine. Let's just collect those whole thing. Cosine, open bracket, k, x minus d. D is going to be 0 since we know that at t equals 0, we're going to start at the bottom. So we don't need to worry about any phase shifts. Okay. Plus c, plus the equation of axes. So let's write down our equation with all the data that we got. We know that, oh sorry, there's one more thing we didn't get, and that's the amplitude. So good stuff. The amplitude is this. Now I leave it in absolute values, but we know that the amplitude is going to have to be negative because we're starting at the bottom, right? So the amplitude is what? The maximum value minus the minimum value divided by 2. Well, what is this equal to? Well, 56.5 minus 0.5 gives us 56. 56 divided by 2, it's 28 meters. Okay, we've got everything. We've got A, we've got the value of K, which is right here. Sorry, it's kind of cramped here. We got the value of C, and we don't need to worry about D because there's no phase shift. So our equation for this phenomena will be, and by the way, I should use T instead of X because that's what they're using here. And we know that the amplitude will be negative. So our equation will be this. Our equation will be y equals negative 28 cosine open bracket k value, which is 4 pi over 5 t closed bracket plus the equation of axis, which is plus 28.5. Right? That's a sinusoidal function that represents this. And this is going to help us to figure out the other part, which is determine the time intervals when the writer could see Niagara Falls. We'll see that on our next video.